All right. Well, welcome. Let's get started here. I hope everybody had a really nice weekend. Uh, you know, Hope you went out to a club and saw some movies, ate at your favorite restaurant, all the things that we like to do on the weekend. I hope you're able to really make good use of that time. Um, so as I was just mentioning before we got started with class, I've started grading on the exams, but it's going to take me a little bit more time than it usually does just because I'm flipping through so many different files as I evaluate those. It's not like I just have the test in front of me and can speed through it at the normal speed. The fact that it was online makes it a little bit more lengthy of a grading process. And so I'm going to try and get through those as quickly as possible, and then when I do, we'll take a look at the solution together. All right, so what you do have on your mind, I hope, is homework number 10. Now, that homework number 10 kind of straddles some of the content that we had before the exam. And so if I pull up the course schedule and we look at where we're at, you've just done the midterm exam on Friday of last week. But this homework number 10, which is due on Wednesday of this week, includes replacement. And so replacement is having to do with economic service life analysis. And so hopefully you'll feel pretty comfortable doing that, which is due on Wednesday. But then today we're going to take a look at some budget limitation type problems, which also has to do with uncertainty. And so that's the last part of the assignment that you have due on Wednesday. The other thing that I'm going to mention is I hope you've been working on the project. It is worth 9% of your course grade, and I have put a let me show you a link to make it hopefully this doesn't screw up the broadcast I'm going to do here. I'm just going to, let's see, make a link. Okay. I wanted to show you that if we go to our course page, okay, there's the project overview video. Now, you've always had access to that video on YouTube, but it's just a link to the YouTube, the class meeting when I gave you the overview of the project. And so I'd really encourage you read through the entirety of the project description. Read every word that's here before you write your report, because I've given this project many times before, and I know exactly what I'm hoping you'll do and exactly what I want you to submit for the project report. And so if you don't read this in its entirety, odds are good you're going to miss something. And if you're still a little bit fuzzy, what you might do is look over this video when I introduce the project, because in particular what I showed was what an A grade report looks like. And so if you want to see a good example report from a student who really kind of nailed it, then I gave an overview during that video. All right, so I'd suggest you keep the project in mind, and so any questions on the announcements before we begin talking about budget limitations? And by the way, I'll invite you to go ahead and turn on your microphone and ask a question with your voice. It's probably more efficient, and you can do that more quickly than you could type things into the chat bar. I mean, if you're shy, you can use the chat bar, but sometimes I don't necessarily notice the little clunk sound that it makes when you type in a comment. So just interjecting with your microphone and asking a question is very much welcome. So any questions on the announcements? All right, well, if there are none, let's talk about budget limitations and capital rationing. Capital rationing arises because every organization has a limit to how much money they can spend, including even our federal government. They've just made one of the largest bailouts it's the largest bailout in world history, $2 trillion as a single event to try and support the economy during the pandemic that's happening right now. But why didn't they make it $3 trillion or $4 trillion? It's because every organization has a limit on how much money is available. And so just as an illustration, I think I've mentioned before that I used to live and work in the United Arab Emirates. And all three of the pictures that are on screen here are projects that were proposed in the Emirate of Dubai, which is close to where I was living. And so maybe some of you have heard or seen pictures before of the world. Excuse me, this is the Palm. The world was a different development. But the Palm is an offshore development that was, it's not a coincidence that it's shaped like this. It was an engineered, man-made set of islands that they essentially used dredging ships to suck up the sand off the bottom of the sea, and then they would pile the sand up in a certain location and they'd compact it, and then they've built really high-end housing, apartments, hotel, resorts, restaurants on this offshore engineered coastline. And so that's the Palm. They proposed it and they did it. You maybe have also seen pictures or heard of the Burj Khalifa. It was built, and I think it's maybe been somebody else has built something bigger, but at one time it was the tallest building in the world, and they've got a really cool observation deck that you can go up there and look around the city. It's a fantastic building, really kind of captures the imagination. But then another project that was proposed but not actually built was the idea that there could be an underwater hotel where there would be a series of rooms and restaurants and observation areas above the water, but then there would also be a section under the water, like a big windows where you could go and have a meal, or maybe even if you were willing to spend a lot of money, your room could be under the ocean. But they never actually built that one because they ran out of available investment capital. There's just not an unlimited appetite for crazy ideas, even in a place like Dubai. They are able to do a lot, but not everything. So what we're going to go over today is how organizations can identify which projects should be selected when there's a limit on the budgets that's available. And so the process for a capital budgeting study is to begin by developing a cash flow estimate for a project, meaning we put together the cash flow diagram that illustrates the expense of construction, the operating costs, the maintenance costs, but then also on the flip side, we're looking at the available revenues that there are going to be. And when we're going to do this process today, we'll assume that projects are either accepted or rejected, and that there's no such thing as partial funding where you're only doing a project part of the way. So it's a binary decision whether you should do something yes or do it no. Now, these are not mutually exclusive alternatives. These are the kind of alternatives where you'll choose as many of them as you can with the available budget. And so because of that, you want to identify which projects are the most profitable, and your goal is going to be to maximize the profits based on how much budget you have available. So it's the budgetary constraint and not the fact that you're just picking one alternative that limits how many of these options you select. So our objective is to maximize return, meaning maximize the profit. Here's kind of an illustration of that process that comes from our textbook, and it's saying that what you would do is you'd look at, first of all, how much is required for each of the three alternatives, how much upfront investment is required, and you'd generate the cash flow diagram for each of them. Each project you'd know excuse me, how much revenue can be generated, and then the capital investment limit tells you how many bundles you can select. Because you can do more than one project, you're looking at what if you do A and B. So you'd add up the initial investment of A and B, and you'd compare it to how much budget is available. And if A plus B is less than the available budget, then that's a package that you could consider, just doing those two. Or you'd look at what if you did A and C. And so you'd look and see, is that possibility, that combination, or bundle as we call it, A and C as an option, is it within the limit? And then later on we'd analyze what's the overall profitability of that bundle. And so for all of the alternatives that are together, we come up with as many permutations as we can think of, or as many permutations as there are, different combinations of the possibilities. So I mentioned A and B, A and C. You could have another bundle be B and C. And then there's another option, down here at the bottom you can see it says select 0 to all 3 projects. And so do nothing is one of the alternatives that we have to consider as a possibility. It may be that the most profitable alternative is none of them. Alright, so this is the data set that we're going to start with for the in-class exercise, and I emailed a file to you at the beginning of class, a PDF of that. If you don't have it handy, that's okay. Here it is up on the screen. We're going to use Excel, but one of the ideas I want to share with you before we get started on the calculations is how many possible bundles there can be. And so you can see that in this in-class exercise hypothetical that I've put together for us, there are 4 different projects that we're considering. We're considering projects A, B, C, and D. Of those 4 projects, each one of them has a different initial investment that's required. And so you can see that project A would cost $10,000, project B costs $5,500, and so on. Well, the first step that we're going to go through in this in-class exercise is trying to figure out how many bundles there are. And the formula for it is that there are 2 to the m bundles, where m is the number of projects that are available. So you can see we have 4 projects, A, B, C, D. What that means is that there are 2 to the 4th possible combinations, and by combinations what I mean is like A and B, A and C, A and D. Those are all combinations. Or another combination maybe would be B and C, or B and D. So there are 2 to the 4th bundles, and if you have your calculator handy, you can do 2 to the 4th power, that's 16. So what I'd like you to do is take a scratch piece of paper. Let me show you the in-class exercise that I came up with for today. For 4 bundles, we know that there are, 4 projects, there should be 16 different bundles. So here in step A, I'm going to pause for a moment while you try and write down all the possible combinations that you can think of. And remember, do nothing is one of those combinations. Let's see if you can get to all 16. Many times students struggle identifying all the possible bundles, but I'll give you some time to write that down. If you don't have this printed, you could just write it on a scratch piece of paper. See if you can figure out all of the 16 different combinations.
Can you do one project?
So the question is, can you do a project more than once? So A by itself is a bundle. A and B together is considered another bundle, but even though A is in more than one bundle. So ABC is a bundle, even though there was previously A appearing by itself and with project B. Does that answer your question?
Yeah, I guess so.
Pattern once I show it to you. All right. So here is a template that I'm going to put everything into eventually. So what bundle possibilities are there? There is A, B, C, oops, that says C, give me just a second here. All right. Obviously D, there is A plus B, AC, AD, there is BC, BD, CD, AB, D, ABC, ABD, ACD, BCD, ABCD, and do nothing. So those are the 16 possibilities. Those are the 16 different combinations of A, B, C, and D. So for example, AB is the same thing as BA. It's not like we'd have a new combination if we said do project B and do project A. Those are the same thing. So let me pause for a moment, and does anybody have any questions about these different combinations that we've put together. So there's 16 bundles, 2 to the 4th, since we had 4 different project options. And then I think we've identified all 16 of those possible combinations. So each one of them individually, and then as many 2 option combinations as there are. So there's A, B, A, C, A, D. So if you kind of think about, there's A, B, and C, and then you're adding different combinations of them together. And then B, so what was there that we could combine B with? There's, well, B and A, but we already have that one. B and C hasn't been done yet. B and D hasn't been done yet. Okay, and now C, the only thing that C hasn't yet been combined with, because we already had, up here was AC, here was BC, so C and D together. So that's the last of our 2-item bundles, and then we go through the same similar process to that with the 3-item bundles. Then there's do everything and do nothing. Okay, now the data that we have is how much each project costs individually. So on your handout it tells us minus 10,000 for A, minus 5,500 for B, 8,500 for C, 15,000 for option D. So now let's find out how much is required for each bundle. Not just each project individually, but each bundle. So for example, project A had a cost of 10,000. Project B has a cost of 5,500. Project C was 8,500. And project D is 15,000. So that's each one of them individually. Now, to get the combinations, I'll just do this. So A and B is A and B, and so then that gives me the cost of the bundle. So go through that same process and find the cost for all the rest of the bundles. I'll again pause for a moment, and if you work ahead and find the cost of each one of them, and maybe you want to create the rest of the formatting to be consistent with what you see. So I'll give you some time to fill that in. Okay, I have the cost for each bundle on the screen, and I don't know if you noticed I kind of pulled a little bit of a trick. You can up here in the top left part of Excel, you'll notice that each cell has a name. And so for instance, the cell that I'm highlighting right here is C5, and you can see that name right there, C5. In addition to its column and row identifier, you can also give it a name. Like you can call each cell something else besides C5. And so for example, this cell is C8, but I can also name it A. And that's pretty convenient later on when I'm wanting to do different combinations and bundles. And so I called this one A, and I called this one B, and I called this one D. I had to give C10 a little bit more complicated name because I'm in row C. It doesn't allow you to name it just C. Like C wouldn't work because it's already column C. So I named it CEE. Okay. So down here I can either type in like C8 plus C9, or the approach I started following after that was, let's see, yeah, down here is when I started using those new variable names. So B plus D, C plus D, A plus B plus C. And so typing that in is easier than clicking on the cell location and keeping it all straight, like the physical location of the number in the cell. So you don't have to use that shortcut, but it's kind of nice that you can rename locations besides just the column, letter, and the row number. All right, now in the assignment, the in-class exercise handout, it said that our budget limit, let's see, calculate the total investment required for each bundle. All right, that's what we've just done. Now a budget limit of 23,500, how many feasible bundles are there? So 23,500 is a yes. We can spend that much, but we can't spend more than that. All right, so here in the calculations, like this would be possible if our budget limit is negative 23,500. So that's the maximum we can spend. So combination A, is that within the budget? Yes. Combination B, is that within the budget? Yes. Well, what if we tried set up an if statement just to make things a little bit easier? And so the if statement that we're going to do is if this number is greater than that number, greater than or equal to, then we want it to say yes, otherwise it should say no. And the reason why it's going to be greater than is because, remember, these are negative numbers. And so since 5,500 is greater than, meaning less negative, than 23,500, then that's what makes it a yes. All right, so here, so I don't have to manually think about each one of those. If we had hundreds of different possibilities, it would be much quicker for us to use an if statement. So equals if, and then start the parentheses. Now our logical test is if this is greater than or equal to our budget limit, and now I'm going to anchor the reference to the budget limit by pressing the F4 button, and then it puts the dollar signs in front of the B and the 4. All right. So if the budget limit is greater than or equal to 23,500, then we want it to return yes. Otherwise, if that isn't true, it should return the word no. All right. All right. So let's see. It seems like it worked on the first one. Drag this formula down. It worked on the next one and the next one. We can go through all of them. So before I let go, what do we expect? Look at bundle number 10. Bundle number 10, CD, that's our maximum budget limit. So it should say yes to CD, but it should say no to ABC, because ABC is too costly. 24,000 is over the budget. So if I let go and it fills that, oh, it said yes to all of them. That's not a very good logical here. Let's see, what did we do wrong? Ah, okay, I know what it did. It's always looking at the same location. So it's not a relative reference. See, it's always looking up here. So let's see. Let me have that formula be instead. I'll type in C3. No. C10. Okay, if C10, and then now that I have a reference to the cell location rather than the actual variable name, I think it'll work this time. So drag down. There we go. All right, so it's rejecting this one because it's too expensive. It's still accepting combination CD. It's rejecting ABC. All right, so now it's functioning correctly. So each time I drag that formula down, it's just looking at the cost cell for the row that we're on. Okay, so the in-class exercise asks how many feasible bundles are there? So our feasible bundles are, let's put the feasible bundles in this second column. A, B, C, D. AB is feasible. AC, BC, BD, CD, and do nothing. All right. So how many is that? Highlight these 10. Down here it says our count is 10. So we've got 10 highlighted. 1, 2. We can count through the list just to make sure. 10 possible bundles. All right. Any questions so far? We're not in a rush, so if you do have a question, we have time. All right. So onward. We know how many feasible bundles there are. Now let's do the capital rationing part of it. So we know that there's 10 acceptable bundles, meaning it's within the limit. If each project has 8-year duration, and we know the MAR is 12%, and we know the annual cash flow, meaning the net revenue, the difference between the inflows and the outflows for each year that the project is in operation. We want to find out the present worth of each bundle, assuming the initial cost that was shown here, and then these are the annual amounts that occur for 8 years. All right. So the costs I can just copy from part 1. So there's A, B, C, D, and I'll copy over the amounts. Oh, no. Because of the name reference again. All right, that's tricky. I got to be careful about that. All right, so C8. Okay. AB cost. AC cost. BC. BD. Hope everyone's following along. This, by the way, it's a good idea to save your work in case you have the program crash on you. So save occasionally. Do nothing is 0 cost. All right, so the annual net cash flow for each one of these options. Let me copy this over. A, B, C, D. All right. So that's the annual revenue that we get for each. And so then AB is going to be A plus B, AC, BC, BD, CD, and then the do nothing alternative has no revenue associated with it. All right, so our MAR, let's see, the MAR is 12% and it lasts for 8 years. It's an 8-year duration, 12% interest. So here we've got N is 8 years, MAR is 0.12. The present worth of the bundle. So it's going to be the initial cost plus then we want to take this annual amount to the present. So we have to find the PV. We're going to do a PV function where this is right now the A. So these are payments. You think of those as recurring payments. There's 8 of those payments. We're going to discount to the present with 12% and then combine it with the cost. So this overall present worth will be the initial cost plus the PV function using our interest rate and the number of years. Be sure and anchor both of those references. And then our payment amount. Our payment amount, we have to put in the minus sign because of how it always flips signs on us. And it's centering, so I can't actually click on the cell, but I want H9. So that's the cell that has the annual net revenue. All right, so what this 2419 represents is you're finding the present value of the 2500. By the way, that is, if we just want to know it separately, the PV of at this rate and this N, and the amount that we're doing is, okay, so this is the PV of revenue, and then we're also going to be combining it with the initial cost. So that's why this cell has, just the 2419. It's because it's the net present value of those 8 revenues plus the initial cost. All right, so we can do the same thing. We can drag this formula down. Let's see, I didn't anchor the reference though to the N, so I better do that. All right, so we drag this down. We find the present worth of all of these bundles. Now remember, these are all bundles that are feasible because they're within the budget limit. The question is, which combination gives us the most profit? So does anybody see the answer there before you? Like, what should the company do? Remember, the decision criteria is maximize profit. So if your objective is to maximize profit, what bundle should you select? Anyone? Which bundle is best? Feel free to use the microphone or you can type in the chat box.
Bundle AC.
Bundle AC, that's right. Well done. You got it.
AC.
You see it too. Good. Bundle AC. So we want the most profit, and here it is. Let me show you kind of an interesting option that's available in Excel. Conditional formatting can make it more obvious to see the correct answer. And so highlight all of these present worths, and if we go into, let's see, where is it? Conditional formatting, and we're going to create a new rule, and format only the top or bottom ranked values. So we're going to select the top one, And then the format that we want to do is select bold. All right. So again, just to show you what I did, I highlighted this entire range of numbers, and then I went to the conditional formatting, new rule, format only the top or bottom ranked values, and I want to format the top one of those that I have just selected, and then the format is going to be bold. Not strike through though. Okay, bold. So click OK, OK, and then what it does is it automatically bolds whichever is the biggest, and it makes it easier to see that we should select bundle AC to maximize profit. And the interesting thing is the most profitable bundle in this case doesn't happen to be the most expensive. You'll notice that there are two other options that get us closer to our maximum budget. So it's not always the case that spending as much as possible is what will yield the greatest return, because 18,500, we're still several $1,000s shy of the maximum budget limit, but that's the alternative that gives us the biggest present worth. Any questions about that illustration? So we looked at conditional formatting, just done capital rationing. So the company should select bundle AC, and it has a present worth of $4,351. And so that is the present value of the profits they get to keep after covering the interest cost that they would incur if borrowing the money at 12%. All right, so this ties in pretty nicely to the homework assignment that you've got coming up. If we just take a quick look at that, let's see. Where is that? I think it is here. So you'll notice that there is a cost-effective analysis, economic service life, budget limitation. So we have a couple of different options, option A, B, C, D, E. You're going to find out which of those should be screened out with present worth analysis, meaning are there some of these options where you're just going to have a negative return, and then of the equipment alternatives that remain, how many bundles are there? Excuse me. So remember, the bundles is where you're finding out it's okay, B and C, B, C, D, B, C, D, E, D, E. You know, like all the possibilities. So 2 to the M, and then you're going to, with the budget limitation, figure out which combination of alternatives is most profitable, following the same approach that we did in this in-class exercise illustration. Any questions? All right, we've done it. Another successful class meeting held electronically. We'll leave it there for today. Let's take one last look at these announcements. Just keep in mind that the homework is due on Wednesday, and then a little bit further out on your schedule, the project. So Friday the 17th. Let's see, today is Monday the 6th, so that's Friday of next week is when that project is due. It's crunch time, in other words. All right, that's all I have for you today. Thanks for joining. I hope everybody's doing well. Feel free to send me an email if you've got any questions or concerns, and I'm going to keep working on those exams so that I can get those graded as quickly as possible. Take care. Have a good day.